I'm Catherine Squires-Hassan, the Director of Culture and Community here at Proline, and I am really excited to be restarting our client learning programs with a different format that will hopefully provide you with valuable information as well as a more accessible format so that we can give the information to a broader group of people. We have 70 people registered for this, so that's fantastic, way more than we could have fit into the old boardrooms. So I'm really happy to have you all join us. And it's my pleasure to introduce Bruce. I'll bring him up in just a second from Stream Energy Systems, and he'll go into more detail on that. I've heard glowing feedback about Bruce from a number of my colleagues, and so I'm really interested in learning what he has to say as well, and learning alongside all of you. Before I turn it over to Bruce, I have just a couple of housekeeping items. One, we will be recording the session, and so if you have to leave halfway through, or if you have other council members who would be interested in sharing the same information, we will be able to share it with you all. You'll give us a few days to make sure that it is in the right format, and then you'll see some emails coming out about that. Also, if you have any questions or tech issues throughout the session, please put those into our chat, and we'll address them as we go through. If you have questions for Bruce, you can put them in there as well. Thank you to so many of you who already submitted your questions. We have provided those to Bruce in advance, and so we will be addressing them during the presentation as well. And I think that's everything for me, and I'll introduce Bruce and have him take it away from here. Thank you so much.
Thanks, Catherine. Hello, everyone. So my name is Bruce Arabsky. I'm with Stream Energy. We're just in the process of joining forces with Energy Savings, which is a company that have a strong representation out of the East, and we're got a lot of horsepower out West. So combined together, we're kind of doing a national rollout, especially with EV charging, but really anything that has to do with energy savings from LED, HVAC upgrades, water saving devices. But EV is kind of the space that I specialize in, kind of my thing. I've been in this space for almost 5 years now. I'm all in on this. I'm a advocate of getting ready for the future. A couple of years ago, when the government announced that in 2035, all new vehicles sold in Canada are to be electric, not hybrid, not something else, but electric. We identified a change coming. Those fundamentals. It's not often we change the way we live, the way we drive, or the way we work. So kind of, I akin it to kind of like the internet, is that it changes a lot of things. And one thing it definitely has an impact on is people that live in condo buildings, in stratified properties. Just not as simple as going out and buying a charger at Home Depot and slapping it in. It's a very complicated process. It shouldn't be, but it is. I predict in 5 years it's going to be a no-brainer. And also new buildings that are being built now are already kind of outfitted, ready for EV charging. Unfortunately, that leaves the vast majority of standing buildings without the ability to charge vehicles. So I've been kind of asking these same questions for a number of years. A couple of years ago, I looked like an idiot in the field yelling, get ready, it's coming. And now really it's just imagine a world where all the vehicles are electric. So you drive electric vehicles, your children drive electric vehicles, rental fleets are electric, fleets are electric, everything on the road is electric. That means everything needs to charge. We seem to manage that with cell phones. We always keep those charged. But we're scared of cars and what it takes. There's range anxiety. There's, what about battery life? What about the grid? What about, all these fears and everything like that. I think we got this. We're smart enough to overcome all those problems. It's just going to take time. I think our biggest impediment to not any of us being buried with too much work is they can't produce cars fast enough. So there's a limit of what they can produce. There's a limit of rolling out. So it's going to take some time. And in that time, we can all get ready. So again, ask yourself this question, right? Imagine the world, but also what does that mean for your life? So at home, at work, and at travel. So again, it's one thing if you're commuting around town, but if you're going further distances, you're going to California, you're going to Toronto from Vancouver, that looks a little bit different. Your travel plans might be a little bit different, but also what does that actually look like in the way of the vehicle you want to choose? And also, if you want to charge, single-family homes versus condos versus, second properties, leisure properties, you got a cabin or anything like that. You go away to a cabin, it's a fair ways away. What do you do to charge? if you don't have the electrical capacity. So it's a thing to think about. And again, it's just a way to future-proof. One day you're going to have to worry about it. Today, maybe not, but it's something to think about. So in my presentation, I kind of dulled it down to the very base level. Everybody has different knowledge of the space, about cars, about charging, about electricity, about the Condo Act, all these kind of things. So I started a basic rate, basically saying nobody knows anything, so let's just start a building block so that everybody kind of understands what we're talking about and why we're talking about very specific things and not talking about other things. So level 1, level 2, level 3 charging, strata properties, common shared power versus metered power, things like that. We're going to get into all of that stuff. So first of all, let's just start at the basics. What is the problem? Climate change, sustainability, and pollution. Those are the problem. The need, alternatives to fossil fuels. So that's what this is all about. Solar, wind, battery technology, and EV cars all have to address this problem as alternatives to burning fossil fuels. So the future is solar, it's wind, hydroelectric, and energy storage. So across Canada, we make energy in different ways. In BC, it's largely through hydro electricity, which is the greenest form of energy. You got nuclear, you've got coal-fired plants, you've got diesel-fired plants, you have solar production. There's a lot of different ways to create energy across Canada, but really this is the future, and this is where we're going. So, and in reality, the world's going to electricity. They're not going to other forms of energy, they're going to electricity. There's some areas that are outlawing the burning of wood, fireplaces, you got to put in electric baseboard heaters, those kind of things, because the world is moving towards electric. So it really doesn't have anything to do with what I think or you think or anybody thinks. It's kind of mandated, and that's the way we're going. So if we look at the automotive industry, number one, the government has mandated the electric car adoption. So again, it doesn't matter what we think, it's being mandated, it's going to happen. You got an ICE vehicle, an internal combustion engine vehicle, you keep it forever, run it forever. But similar to the old air care plan, where they brought it in, they started air care and everything, and eventually all the old pieces of crap that were spewing glue out were gone because you got tired of trying to fix them. They all went away and they closed the shops. Success, right? Not a failure, that was a success. Same thing with ICE vehicles. One day it's going to be too expensive. I think one of the biggest turning points was the price of gas. A couple of years ago, it's $1. Now it's over $2. A big problem there. So again, all new car sales in Canada must be electric, and that's all electric, battery electric by 2035. Big change in the way we do things. Most new car purchases will be electric. We hear that kind of from people saying, well, I'm waiting for the right model or the right make to come out, or the right range or pulling power or whatever. But they're kind of thinking my next vehicle is probably going to be electric. Some don't. Some are, the diehards, and good on them. It's just it's going to be expensive to maintain a nice vehicle. So the auto industry, as you probably well know, virtually the entire planet are all going electric. They're all opening plants, they're all opening partnerships with battery manufacturers. LG just announced a $4 billion plant they're building in Ontario. This is all to produce products for all the autos that are being produced. So again, no matter how you feel, the auto industry is going electric. So it means we're going from the pump to the plug. So that looks a little different for all of us. So recharging levels. Let's just cover this one. So there's 3 types of charging levels, 3 categories. One is level 1. So every vehicle sold in North America comes with a level 1, as we call a trickle charger, right? So it basically designed to go into the wall socket of the wall. Very simple device, nothing fancy about it. So it runs on a regular 120 volt outlet. You can put a 15 or 20 amps breaker on there, which will produce 12 to 16 amps of power to the car, right? And that'll produce about 7 kilometers of driving range per charging hour. So you come home, you park it all night, you charge for 10 hours, you're going to get 70 kilometers of range. This is very popular with hybrids. They have generally 70 kilometers of range. Come home, you need 35 kilometers of range. Pretty easy to charge it up. If you're a commuter and your range is around 400 kilometers and you're driving 100 kilometers a day, this is going to be a challenge. The biggest problem with this category is there's no rebates available in this category. The government says this isn't sustainable. We don't want this. We want something else. So they don't really support that. But again, you don't want to drive off the lot. You can't drive up to a gas station. you got to charge it somewhere. So that's why it comes with a charger. Level 3 is at the other end of the spectrum. So these, number one, very expensive, not grid friendly. I don't know if you've noticed super stations that are spread around the province. They're in awkward places, and the reason they're there is because that's what the power is. So BC Hydro or Fortis or US Minister of Power, where it is, they say you can put it here. Well, we'd like to put it over here. You can put it here, and that's just the way it is because it takes a lot of power. So one of these superchargers is enough capacity to power 5 single-family homes. They're very expensive. Again, not grid friendly, but they do deliver a lot of power. So this is for charging on the go. Okay, so you're traveling across Canada. You're not stopping at one of these stations and spending 28 hours charging. You're going to go to these stations. Now, the limiting factor in this station, just an FYI, is a lot of the power is at 50 kilowatts. It's a good charge rating, but pretty well everything's been expanded now to 150 or 250 kilowatt charging capacity. The biggest limitation is most electric vehicles on the road can only charge around 50 to 70 kilowatts. They can only take that into their battery at a time. So you go in there, you plug into a 450 kilowatt system, you're still only drawing 50 kilowatts. So it's a limitation on the vehicles. The new generation of vehicles are going to get faster and faster ability to turn power into range and storage is going to get better and better and better. Most of the Tesla superstations are now 250 kilowatts. They're starting to upgrade to 450 kilowatts, but that's a lot of energy being used in a very short period of time. So a typical Model S, you can charge your battery fully, in under 15 minutes at a superstation. It's getting close to a fuel up, but again, it's charging on the go. This is a solution for home. So then we talk level 2. So level 2 is similar to a dryer or an oven plug. It's a range plug. It's 208 volt, runs at 40 amp circuitry. So there's a 40 amp breaker, goes up, hooks up to your charger. This will deliver about 45 kilometers of range. It does range by vehicle or depend on vehicle, but generally between kind of 40 and 50 kilometers, that's what you're going to get per hour charging into this circuit. So this is kind of the sweet spot. Number one, this is where all the rebates are. So the government wants everybody to put it in. And number two, this is the most grid friendly. So the idea is similar to your cell phone. You go to bed at night, you plug it in, you wake up, you don't know if it's finished charging at 1 a.m. or 3 a.m. You don't care, it's fully charged, you're good to go. Similar to your car, right? The beauty about being at home is when you plug it in, it doesn't have to be charged for 20 minutes. Right, so again, very grid friendly, and we promote systems that actually have the ability to dial the power down. So say 7 people come home at the same time, they all plug in at 5 o'clock. That's the highest peak demand in your building. You don't need charging right there, so it throttles it down and allows it to be throttled up when the power is available later on. So again, it saves money, but it also is a lot more grid friendly. So this is the spot, and this is level 2. So everything I'm talking about today is about level 2 charging. Recharging technology, popular question here is, if I put in a charger today, is it going to be outdated tomorrow? So how I like to use the analogy is, again, a cell phone. So a cell phone 20 years ago, the flip phone was the rage. You plugged it into a wall outlet. You didn't think much about the charger. Today, the cell phone has become an incredible piece of equipment, very sophisticated, still plugs into the same outlet, pretty much with the same charger. You change the charge port, but I think there might be a reason for that. That isn't practical. But regardless, we see the same technology. The charger on the wall is actually producing power for the car. All the competition is in the car. The device on the wall produces energy. It sends amperage and voltage to the car. What the car does with it is up to the car. So the battery technology, its ability to transfer power to range, is all on the car, and that's the race. This is the technology. So this and this are the same race. This device on the wall, the actual guts of a charging machine are pretty much the same across most of the solutions that are available in Canada. They're basically a glorified power bar. They produce power. That's it. Where they differ is how they meter, monitor, and communicate with the outside world, and you have the ability to control them and get information and usage and things like that. But the actual charging function is virtually the same. So there's just over 40 solutions available in Canada right now, different makes and models, so charge point flow, switch, things like that. But there's over 40. The top 15 for quality, identical under the hood. It's just how they communicate, again, whether they use cell, Wi-Fi, or radio spectrum. So again, this over time, as the cars develop and get longer battery range, the battery technology gets better, this unit on the wall will still produce that 40 amps or technically 32 amps to the car. So again, when we look at the space, basically EVs will be charged in these 3 areas. Either at home, you'll charge it at work, or on the go. So these are the 3 areas. And this one really right here is what we're talking about, is what does it look like at home and what is the right solution? So the big question is your property ready? And how we term it is not only is it ready, but is it EV ready? And that's a term that we've kind of coined. It's used a lot in the industry. Probably even heard about the EV ready plan. So what it is, it basically says, let's look at your entire parking garage and install, what would it take to install the infrastructure so that one day you have the infrastructure in place that's energized and ready to go. And then owners at any time can put in a charger. They don't have to put them all at the same time. You don't have to put in equipment now. You just get it EV ready. So this building is EV ready. There's no chargers. And that's really where another kind of issue you've got to remember is that we're also talking protecting property values. You know, the new buildings going up are 100% EV ready. So somebody purchases or rents in a building that's EV ready, they can just either buy or lease a charger and they're good to go. Your building's sitting there saying, well, can I charge a car? Oh, no, you can't. You got to go across the street, park at the mall, and every 2 hours go get your car and bring it back. And pretty soon it's like phone somewhere else kind of thing. So we see that kind of developing a couple of years in the rental market. People are saying, well, if I rent there, I'm planning on buying an electric vehicle, I want to future-proof my decision. Can I charge there? And they say no. So they're looking around for properties that again, most of their new rental buildings are all EV ready. So there's been, in regards to how you feel about electric vehicles, you also got to think about protecting property. So again, once an owner in a building can decide to install a charger as needed, and then when the charger is needed, it's basically just pipe down and install. Again, no one really knows the adoption rate of EV chargers or EV cars. It varies by region. Obviously, BC is very, very strong in the EV markets, been the leader in North America for the last 2 years. Just around 20% of new vehicles have been electric, which is great, but also, it's forced all the jurisdictions in BC to tackle these problems. No other jurisdiction in Canada has gone in and put in a permit for 1,000 chargers in a building. We did a building in Langley. There's 8 towers over 1 parking garage with 1,005 parking stalls. Let me tell you, the jurisdiction having authority had a little bit of concern saying, what's going on here? How do we regulate this and know so that it's going to work and all that stuff? So it's a challenge. It's new for everyone, right? But we're figuring it out here, and it's going to help the rest of Canada adopt chargers. So again, once your building is EV ready, you have the convenience and peace of mind. So don't worry, if you sell one day, you can sell it as EV ready. If you decide to put in an EV charger or not, you're really protected. You don't have to worry about it anymore. Again, you can either protect or actually increase your value. We were told a couple weeks ago that they see about a 5% increase in property values if you have private level 2 charging in your parking stall. So this isn't shared visitor parking. This is actually a charger you can come and just use as much as you want. Plug it in when you come home at night and leave it plugged in all night. You don't have to go down and move it every hour. So it's a huge convenience, but it's also an asset appreciation vehicle. And again, future-proof your life. What do you want to do? You want to sell? You want to move? You want to stay? You want to be electric? One of your children wants an electric car. You can decide to do that, and your property doesn't become a liability when you decide to make a transportation change. Recharging solutions, as I mentioned, there's over 40 solutions. Some of them you probably recognize. Some of them are very brand. One of the first movers in Canada, in North America, was ChargePoint, huge company out of California. Technically, they're a SAS, kind of a software as a service company. They're big on the software end. So the big question is there a difference? And if there's a difference, should we care? And one of the things that what we found in doing a lot of installations, so we've visited almost 1,000 buildings in Western Canada. and done capacity studies. And the overwhelming majority of buildings have capacity to do EV charging if it's done in the right way. But there's a lot of systems that just don't generate the value long-term for buildings. So we're big proponents on a very particular type of system, and I'm going to talk about it today because there is no other system available in Canada or in North America at this time that could do the same thing. But it applies to strata properties. Strata properties behind the residential gate. So if you look at charging, public access charger is quite different than a private one in your home, in a garage, a single family. Nobody cares that it's there. Nobody knows it's there. It's not on somebody's app saying, hey, that guy's got a charger, I'm going to go use it. It's totally blocked off. It's a private use charger. Now, say you're going to put 100 of those in. Well, again, there's no public access. Nobody has to swipe it with their credit card. And also you're using common power. So all of those variables make it a kind of a walled garden where you have opportunity to, number one, save on energy, and number two, plan it so that it's least cost and most cost effective to implement a system that can kind of take advantage of this community of chargers, unlike outside the residential gate. So the system I'm talking about is we recommend behind the residential gate, not in visitor parking, not in guest parking, not in public access. There's a lot of other solutions that are better in that space. But this one with all of the key elements is what we recommend in strata properties, and we put in almost 300 of these systems in BC to date. They work great. Councils are very pleased. We have some that Proline have done, and the Belvedere building is one that is kind of a showpiece because they kind of walk through the whole system. They're the first building we did in Victoria, and they're happy with the system, but they're proud of their decision because going in a different direction, they see how it differed from a lot of the other solutions out there. So it's based on an energy management system, and this is key because if you say like there's 5 different solutions and they're all about the same price, right? So what is the difference? This is what the difference is, because once you install it, you're going to pay energy for the rest of that building's life. And we believe the systems we're putting in these buildings, they'll be there for the life of the building. Nobody's going to go in there and rip out 100 chargers and put in a different system. Number one, they're going to work for the life of the building. No problem there. And number two, the technology is not really going to change. So when we look at the way billing is done by BC Hydro in BC, is that they charge buildings in 2 fashions. Number one, energy consumed. So that's what it takes to run your building, right? And generally that varies around 11 cents a kilowatt hour. Very, very cheap on a global scale, right? That's double, triple, in parts of Europe, it's $1 a kilowatt hour. So when you think about solar and wind and other, energy, solar is competing with 11 cents a kilowatt hour. In Ontario, when they said, we'll give you 90 cents a kilowatt hour if you put it in the solar field, they have the largest spike of solar installations the globe has ever seen. It's a no-brainer, not at 11 cents. As we see the grid start getting taxing over time, you're going to see the energy price going up and up and up, right? Someone's got to pay for roads and taxes and all these things that we hope they don't put on the EVs, but they will. And they'll probably put it through electricity. But regardless, they got to expand the grid. They got to build it out. So I believe this price is going to get a lot higher. And as it does, these other technologies like solar and wind and everything start to make sense, because now it's not 11 cents. It might be 25 or 30 cents a kilowatt hour. Totally different dynamic there. So it's good. BC, we got very inexpensive energy, which is great. But we do pay on 2 ways. Strata properties in BC pay the same rates as commercial properties and industrial. They don't pay the same as residential private homes. So private homes have tiered, right? You use this, you get into this tier, you pay more, you get this, and you get more. You hit the ceiling, you can use as much as you want. That's a tiered system. Doesn't apply to strata properties. I don't know why. I don't think it's actually fair because it is a home. Regardless, they put all the strata properties in this category. So strata properties are paying 11 cents a kilowatt hour for all of the energy they use, but they're also paying up to $12 per kilowatt of your peak demand. So if you notice in this building, and this is actually the demand of the building, is that through the night, demand's pretty low, it comes up through the day, it spikes around dinner time, and then it trails off. Okay? Your average would probably be about here, but for some reason, perfect storm, the building hits high peak demand. This is right around 5 o'clock in the afternoon. Fairly typical. We have buildings that hit at 3 p.m. and some at 10:30 at night. It's kind of all over the map. But for demonstration purposes, you're going to pay, say, a couple $1,000 for energy, and then you're going to pay $12 per kilowatt. So this building is sitting at about 160 kilowatts. Peak demand times $12. If this goes up or down, you pay that times $12. Doesn't matter how much energy you consume. So this is key to remember, because on a typical bill, and we've looked at a lot of bills, is that about 30% of the strata bill is made up of peak demand charges. 70% is the energy you need to run the bill. Fair enough, right? But if you look at peak demand as being $2,000 in cost, and it's because of this peak, not because of what you're consuming. So now we have electric vehicles. Now, this is a scenario. I'm not saying it has to be this way, but this is for demonstration purposes. You have some EVs, they come home, right? They come in at the absolute wrong time. They plug in, so of course they're going to drive demand. So this is 10 EVs driving what they would need for demand, 10 times 6.6 kilowatts. And if you notice, they're charging. Nobody knows that they're charging at the wrong time, or that there's a peak, or anything's going on. But the impact of this is not on energy consumed. The green area is hardly moving at all because they're not taking that much energy. The problem is they're taking it at the wrong time. This with 25 cars charging at the same time per peak is an extra $2,000 for 25 cars. Now we have buildings with hundreds of vehicles in them, and you can see the impact of it. So the problem with this scenario is that unless you're actually looking at what the building's demand is, you can't control what the chargers should be doing. So on most of the systems, they just don't have that technology to know what the building's doing. So with an EMS-based system, which is energy management system, what happens is the energy management system, we tell the energy management system that the peak is 160. So when it sees power going to 160, it basically throttles the chargers down just over this peak period, and they extend out a little bit. But here's the impact. You're charging cars using 11 cents a kilowatt hour, driving no extra peak demand. The other horror story of peak demand is that peak demand, everyone in the strata building pays. You can't track peak demand. You can track how much people use for energy. You can't track if they're actually driving peak demand. We've had buildings that we've actually gone to and they said, our bill's gone up by $4,000. We've got 8 people with chargers. We're charging $50 a month. What's going on? I think we're driving the energy right into the ground. We did the math, peak demand. They asked us to come in and swap it out with an EMS system. Gone. They saved $4,000 a month just with the EMS system. So if you're wondering why I'm passionate about this makes a big difference in strata buildings in the residential parkade behind the parkade. So how the EMS system works, I'll just quickly go over this, and then it's kind of basic fundamentals. So you have your hydro meter that comes in, you get your main electrical service, and then it goes off into your building. So your meter stacks and all your power to run your building, your home over here. Then you have your parking garage with a bunch of chargers in it. You got your EV charging panel. So normally this is just a separate run. It's run into the parking garage, and then through circuit sharing, it just operates the chargers. No brainer. The EMS, so if you notice here, so this is a system, this is what we call a dumb system, right? It'll operate these chargers. So if you take like a flow or a charge point or all these things, it'll make sure that these chargers know it's sharing a circuit, right? It's 4 to 1, so there's 4 chargers on one circuit. These chargers know they're on a shared circuit, so they'll behave nicely. If one's charging, it'll take all the energy of 2, it'll split it between 2 of 3, and take another 3. But these chargers, this system, has no idea what this is going through. So with the EMS system, the EMS actually goes right between the hydro meter and the main system. So it's looking at exactly what BC Hydro's looking at. And that's all we care about, right? Is what are they going to bill us on? So what they do here is with its eyes on what thing is as the building's demand kind of fluctuates, and this is done in real time, so it's not somebody looking at it or whatever. Again, it's set at 160, it's monitoring. So as demand in the building goes up, What the EMS does is detect that there's a problem, and it sends out a signal, and it actually starts throttling the chargers all down over that peak period of time. As soon as that peak period is done, usually it lasts 15, 20 minutes, sometimes a little bit longer, a little bit less. Sometimes it doesn't happen at all, but it's monitoring that to make sure that it's reactive to that type of incident, and it prevents all those extra charges. So again, this is the system without EMS. This is it with EMS. This bar right here represents the 25 cars charging. Again, they charge well throughout the day. Over peak, they're throttled down, and then they're back home. And again, there's a little bit of makeup time, just to make up for the time that it's throttled. Very effective. We see it very usable and very dynamic in a lot of buildings across the BC. So we look at recharging components. A lot of people ask, so what am I actually buying? So how we look at it is Strata is responsible for the infrastructure, getting the wiring and the power into the parking garage. Once it's there, the owner is responsible for these items. There's 5 basic items. Number 1 is the charger itself. Number 2 is the charging port. So we recommend and usually outfit it with a 25-foot charging port. There's a cord hanger, so you can put it somewhere on the wall. And again, you don't need access to the charger. So say you got something in your parking stall, like a hood vent or something. The charger can be put anywhere. You just need to get at the nozzle, right? So we recommend a separate cord holder so that you can always get at the cord. A 25-foot charging cord, and then a universal J1772 plug. If you know what that is, basically a J1772 will charge any vehicle sold in North America, including a Tesla or an Audi, which are proprietary. They can use the J1772. But if you buy a non-Tesla vehicle, you can't go up to a Tesla charger to charge. So we don't like the walled garden to stay in the universal space. We've seen a lot of people put in Tesla chargers in their private homes, and their asset becomes a liability because people want to buy their home built on a Tesla. And they're like, what am I going to do with this charger? Take it with me. So we recommend staying in the neutral space, which is J1772 universal standard. We also install a wheel stop, which is the way to protect the charger being damaged by a vehicle. Mounting options. Another problem is a lot of creative parking solutions out there. So obviously the basic installation is the center of a single stall. Again, with the wheel stop to protect it. If you own 2 parking stalls that are adjacent to each other, a lot of people elect to put one charger in the center. With a 25-foot cord, you can charge both vehicles, whether it's front or rear port charger, whether you drive in or back in, without moving the vehicles around. So you just go out there and move the nozzle over. Again, with generally 9 to 10 hours of downtime, it's easy to charge 2 vehicles. We have people that are charging like 4 electric vehicles using one charger, no problem. If you don't have a suitable wall, but you have a column at the front or nose end of the parking stall, we can also use that. So if this part's open, or there's some intrusion there, we can use a column. A lot of people want us to install a column on the back. That can be used by electrical code. You can't put a charger on the back because you can't protect it. Also, when you leave the stall, you might catch the cord on your side mirror or damage something without knowing it. But if it's at the front. If you don't have a wall or suitable column, we install what we call an EV pillar, and this pillar goes in between, so it's bolted to the floor and the ceiling. It's a metal enclosure, and you can install the charger on both sides so that both vehicles can have a charger of their own. Again, you can share one charger if you own both parts. One of the more contentious issues is this wheel stop. A lot of people think it's going to bump them out into the drive aisle. They don't like anything encumbering. So by electrical code, it must be installed, and the minimum distance must be 42 inches or 107 centimeters from the wall that the charger is mounted on to the wheel side of the car, wheel side of the stall. 42 inches if you walk through your parking garage. Basically, everybody's parked that distance anyways, unless you actually hit the wall. You usually stay back. The larger the vehicle, the greater the overhang, the more you have to pull back. So if we go in and just measure it out, it's basically a non-impact. We've never seen a car or a parking stall being compromised by a wheel stop. We don't recommend bollards or shrouds because if you put something in a parking garage, someone hit it. I guarantee they hit it, scratch their bumper. Once in a while, somebody else parks there not knowing it's there. With a wheel stop, these are only 4 inches high, so they're very, even if you got spoilers and stuff in your car, they're not damaged. So Without taking a break, I'm moving through this fairly quickly, but the next kind of like subject is, okay, so what does a new project look like? If we're gonna start a new project, what does that look like? So we know the technology, we know what's going on. So first of all, and this goes kind of to the property management side of the thing, is that we require site information. So the very first thing is, well, I got a building in Victoria. Great. Can you tell us what is the strata number? What's the address? How many residential units in there? And year of construction. And all that allows us to do is have kind of a profile of the building. We're talking a 20-unit building, a 200-unit building, underground parking garage. What year was it built? Because strangely enough, the older the buildings, usually the more capacity they actually have. The newer buildings, they're actually tightening the capacity. So a lot of times we'll go into older buildings and say, oh, this was built in the 70s, it doesn't have capacity. You got tons of capacity. Because back then, engineers said, what the heck, let's put it in. Who knows what they're going to do one day, right? So is that, maybe factor. Now they're not making so much. They're like, can we save money? Get that, transformer down. So this helps us just get a profile so that when our technician goes out to site, kind of knows what to expect. And we kind of know exactly how much time it's going to take to kind of walk that property. So when we do a site visit, we generally just need to see the main electrical room, the main communication room, and then walk the parking. It usually takes about 20 minutes, unless there's 8 or 10 council members there that want a lot of questions, then it might be 2 hours, but generally the technician stuff takes a fairly short period of time. So then the site visit itself, again, the initial site visit, I try to go as many as I can. I love seeing buildings and kind of getting a feel for them. But we send a technician and they're basically there just to get the data. So they take pictures, they take measurements, but the main thing we're looking in the main electrical room, what kind of gear is there? Number one, is it still available? Can we still buy this stuff? Or did somebody buy this company and put them out of business and it's no longer available? That's the big game changer where you can go from a $20,000 problem to a $200,000 problem. So that's the main things we're looking at, is technically what it is. Everything from there is pretty much cookie cutter. We know lengths of runs and wire capabilities and all that kind of sizing is easy to do. So that's what we do the site visit for. So again, we need to see the main electrical room or the vault. So that's the BC, usually has a BC Hydro sticker on the vault room. The main communication room, because all the systems we put in do need connection to the internet. And there's one thing no building currently has, is a connection between a comm room and the main vault, because there's no low voltage equipment in the vault. So no one would ever run an internet line there. So part of our system is we just need to know where that room is and what it'll take to run an internet line to our EMS system. Visit takes about 30 minutes to be done unaccompanied. So if you give trade keys, we do the runaround. A lot of times it helps if there's a building manager or somebody that knows the building and find things a little bit quicker, but eventually we find it. And one of the things I find most lacking are drawings, electrical drawings. Either they're not available, and then the ones that aren't accurate. They're not as built, and even they say as built. We go there and it's supposed to be a 1200 amp service and it's 800 amp service, and it goes over time. So we always go to site and have a look at it. And again, so all we need is just the appropriate person to contact to actually get it. So hydro data. The other thing is, so what we require is 12 months of the past year's hydro bills for that building. What that allows us to do, even if you've had another electrical contractor do an EV ready study, is that we need that data because we will redo the study. Because in the end, we're the ones that have to pull the permit. We're the ones that have to guarantee the system's designed properly. And that data isn't, we can find all the data that we need on the BC Hydro invoices. So we don't need a summary or a spreadsheet. We actually just need the invoices, and we can draw that data. So again, we need the actual invoice to pull up the historical data. And most of the permits require that we've looked at 12 months and basically say, what does it take to run this building for a year? What's the peaks? What's the valleys? And what's the usage? And that's the basis of that. So then the next steps after that. So after we've done the site visit, we kind of do the analysis, we do the costing. We'll provide a site review and a proposal. And in that proposal, we will give you a proposal depending on what you ask for. We give you both, but predominantly right now what we're doing is EV ready. And so definition of EV ready is, can this building support one level 2 charger for every residential unit? Not every parking stall, every residential unit. So does everybody have the right to one? And if you can, you get all the rebates. If it can, you can get some of the rebates. So we like it for all the rebates. Now, a lot of people say, well, if we have capacity, can we give a charger for every parking stall? Yes, you can if you have the capacity. That's definitely a feasible thing. But like the low watermark is to say, can we at least provide one for everyone? And if the answer is yes, at least you can move on through the great politics and get it through the system. So we also offer a turnkey EV charging solution. We don't do here's a system you manage it. We found most of the systems we've gone in and ripped them out and put in different systems now. One council might say, well, we'll just calculate everything and bill everyone. Another council comes in and goes, what do they think? Like, I don't have time to do that. Or it ends up on the property manager's plate, and then they end up, their fees have to go up because they're spending hours a week, billing for systems. So similar to a gas pump, if you notice, you never drive into a gas station and there's just a hose on the wall and just says, give me $50 and go fill up whatever you want. No, it's metered and monitored and tracked for every user. We recommend that in strata properties as well. It's a fair and transparent way to make sure that nobody else is subsidizing the charging that's going on. So in our proposal, we outline the main elements, the project scope. So what are we looking at doing? The cost, the actual estimate for the project, eligible rebates at the time, and EV charging costs, and the recovery options. So again, how are you going to collect the money that Strata has to pay BC Hydro for all the energy we use? And how do you make sure that no one that doesn't have an EV is not subsidizing those costs? And that's part of our kind of key element here. Then we either apply or reapply for the pre-approvals. So what we recommend is if a building is saying, okay, we're thinking of doing this, okay, even if you're thinking, it might take a year to think that through, apply for the rebates, get pre-approval. If you have to stand in front of your owners, you can say, we've already been approved for $120,000 of rebates. Like, we've been approved. And what they do in this approval process is they take that $120,000, they give you an approval number, they set it aside. So say 2 months, they say, no more, we ran out of money, no more rebates, they'll still honor that $120,000, as long as you do it within 4 months. So there's some flexibility there, but it also helps. There's a big difference between we might get rebates and we've already locked it in. So we do this right up front. Again, this is before a lot of other steps, but we recommend the pre-approval because it also takes about 30 days to get pre-approval. And we do that work at no cost as part of our project. So facilitate monitoring agreement between Strata and the service provider. So that's, once we put a system in, we put all the chargers on the network to make sure everything's working. We put everything to sleep and we walk away. Then in this situation, Unico Power or whoever that service provider is walks in and says, okay, how much do you want to bill people? What's the mechanism you want to use? How much, this is our agreement. This is what we'll deposit the funds into the Strata account, once a month or whatever. So that agreement is between the service provider and the Strata council or the Strata property. If there's a problem with the charger in that building, the service provider, say it's Unico Power, will do a diagnostic over the air. If there's an actual problem with the physical charger, they dispatch us to fix it. So that's the relationship. But once we leave, it's really up to the product or the service provider to take care of the system. So we, at this point, we often recommend scheduling a question and answer session with council. Make sure that they're all understanding what the proposal means, what it doesn't mean, what's involved. There's usually quite a few questions. So it's a really good, valuable time to meet with council. Then arrange a town hall, which is basically just an EV info session with the owners. I just did one last night in Port Moody, in BC. 137 unit building, and about 80 people show up for the session. So a lot of interest. And we're seeing that more again, especially since gatherings are getting together again. That can be done virtually or in person, either way. We do offer policy and bylaw assistance. So we have kind of every time we go to a building and they run through their lawyers, we say, okay, this is better. Okay, we'll use this one. And then we just give it to our managers to kind of look at it and tweak. So that helps a lot. I think we're getting to a point probably within the next 6 months to a year, everyone will have kind of a blanket policy that they can use. Right now it's still a little bit of a no man's land there. So again, we will, if warranted, we also recommend if there is a special SGM held or AGM to vote, is that we show up to a short little presentation, a recap, especially once we've done the town hall, but a recap, and then that's usually the town hall is attended by people that are in favor of the system, and then the vote is attended by people that are against the system. So that's a point just to address the concern. And one of my things, obviously, I have a vested interest, but one of the questions is, why would you want to prevent others from having a spill? Unless, and a lot of people just aren't big on EVs, fair enough, but, there's property value concern and things like that. So there is some legislation across Canada that's rather interesting, the right to charge, going into the Condo Act and things like that. In Ontario, they got, I think it's 60 days to respond to somebody's request about a charger. So there's a lot of recognition that this is an issue. People have a right, exactly what those rights are, and at whose expense. So again, just to kind of answer some of those questions before voting. So if we're approved and we get the project, this is what it kind of looks like. Is that so we provide an EV charging installation agreement. So we basically take the proposal, we spin it into an agreement, it becomes a legal agreement, and it just reflects the proposal. We apply for the permits for the project. Again, that can take some time, especially as the systems get bigger and bigger over time, and jurisdictions have an authority kind of want more things, and they want engineered drawings, and they want pre-approvals of different things. So we go right into the permit process. And then once that process is kind of in the works, we assemble the equipment and the materials needed for the project. So we keep a lot of materials and equipment on hand, because lead times are very, very long right now. Then we work on coordinated access, storage. So we have equipment, we have to put it somewhere in the building, parking for our crews, work schedule. If there's times we can't work, we do a lot of multi-use buildings where there might be a hotel or a clinic in the building and a residential park. If you're on P1 and there's a hotel above you, they got meetings going on, they want drill engine banging and stuff like that. So we make sure that we work on a work schedule with council of building management. And then site communications. So when we're in the building, we need somebody to communicate if we need vehicles moved or we need to block off certain things. Just need somebody to work with directly to make sure that everything's done seamlessly. So then we do a site visit. This time, our operations manager goes with the crew supervisor, the person that's actually going to do the job, and they kind of map out how they're going to attack the job and kind of get the feel for the building. We assign a project coordinator, so this person's not on site, but they're the ones that our crew is in charge of getting the work done. Our project coordinator's in charge of making sure everybody knows what work is being done. So between the council, property manager, individual owners, and also just the way we do our kind of project management. Somebody approaches our crew in the parking garage, which they often do, and they ask them questions. They give them a business card and say, "Please phone this person," and it's somebody from my team because we answer all the questions. Most of our crew, number one, they don't know all the answers, and number two, they're there to work, not to be a public friend. So that's not meant to be offensive. Just want to make sure you get the right information. We appoint a sales and information contact. So again, people say, I might want a charger. I'd like to talk to you about, do you offer payment plans or do you, different thing? And I've heard different things, so whatever. So again, it's not anything the crew or project coordinator has to deal with. We have a sales and information person who just kind of handles that on everybody's behalf. So then we set the project state. Once we have the permit, we kind of got everything arranged, everybody's comfortable with what's going on. We set the project date and we set out the timelines. So by then we kind of know if there's any equipment shortages, if there's something we might be waiting for. So phase one is the infrastructure. So we go in, there's no chargers. It's just a lot of work in the electrical room, a lot of work into the parking garage. We generally work down the drive aisles, not in over top cars and anything like that. But that's phase one, and that takes about 3 weeks on most buildings. So when I'm talking buildings between kind of like that 50 and 150 parts. Where, that 1,000 unit building I was talking about, that took 5 weeks of infrastructure. So a lot to do there. During this period of time, if you notice this is going to take 3 weeks, we've already set the timeline, is that this is when people can sign up to get a charter. So if they're interested, there's a period of time. And we generally offer a discount for anybody that signs up during the first phase. This is the most efficient time to put in a charter when we're doing the infrastructure. We have the crew, we have the permit, everybody's there. Perfect time to put in charters. If you want a charter, put it in, get on the list. And so when we finish, we basically phase two is that we put in all the charters that have been signed up. So then once that, and that takes about a week, depending on access, we arrange access of the parking stall directly with the owner. Say, about Tuesday between 10 and 12, we're going to put it in. Can you vacate your stall? Yes, okay. We go in there, we put the wheel stop, we hang the charger, connect it to the backbone, good to go. After final electrical inspection, the system's commissioned and tested, and then, like I said, we just basically put it to sleep. It's good to go, and we're done. Phase 1 is over. Phase 2, after this, once we kind of leave, we clean up and we leave, that becomes another kind of a price for the charger. And what that includes is us rolling a truck to put in one charger. So we pull a permit, we run a truck, we schedule the installation, we do the installation. So there's a little bit of added cost. In most buildings, some of them, ideally, especially if it's suddenly there's a rash of people signing up, if there's 2 or 3 people signing up at the same time, we can take that permit cost and divide it over 3 people instead of one person having to pay the extra cost. But more or less, it just reflects the fact that we're rolling a truck to put one charger. Not a great efficient way to do it. But usually when somebody wants a charger, they want it in yesterday. My car arrived, I need a charger. So we can be responsive, it's not always the best price point. So again, there's a number of agreements that we need to go through. And again, we supply all of these ahead of time. You can mull them over. A lot of them do get changed because of particular things. But the EV Ready installation agreement, again, this is between, it reflects the scope and the final agreement between Strata and our company. It includes all the warranty information. So what's being warranted, the system, the chargers, that type of thing. We get a permit authorization letter, so that actually officially says we're allowed to pull a permit on behalf of the Strata building. Again, we just facilitate. Whatever you say we're going to charge 15 cents a kilowatt hour. Fair enough. You get a contract from Unico Power that reflects that they're going to charge owners 15 cents on your behalf and give you back the money. Again, Strata Council has to decide what is the recovery rate you want to charge. Is it a flat rate or is it cost per kilowatt hour? Just you can legally set it to anything you want. We have buildings that a vast majority of our buildings set at 15 cents a kilowatt hour. That's based on around 11 to 12 cents a kilowatt hour of cost, and it covers all of those like taxes, extra things that get built into it, and an annual operating permit, which is required on the EMS system, which is around $120 a year. But again, it ends up being zero cost to any non-EV owner, based at 15 cents. We do have buildings that charge over 20. One wanted to recover its cost, so it's charging 24 cents a kilowatt hour until they recover their money. Totally up to council to do it. Unico Power will do whatever council says. There is a carbon credit eligibility program that just came into place about a month ago. And what it does is it reduces your monthly monitoring fees if you sign a carbon credit agreement. And there is a carbon credit right now. It's kind of a loosey-goosey thing right now, but Unico Power is involved in the federal carbon credit and provincial carbon credit program, so it can use meet some savings, and that's included in this agreement for council to look at. Another one, again, a lot of times people wonder about this. So we need an internet port. So it doesn't have to be broadband. It doesn't have to be a great fast connection. We just need a port. You don't have to wire it anywhere. It doesn't have to be wireless. Just an available port that's open to the internet. We'll get a wire to it, but we need a port. So we can't order a port. We can't put it in. Something that Strata has to order from either TELUS or Shaw or your service providers. So we just need a port available, and that's where we plug the EMS in. And that's how it communicates with the outside world. And then again, there's a form where, because of annual operating permit is actually issued in Strata's name, and then it's registered as Unico Power being the one that's actually managing the EMS system. So if the city of Victoria wants to know who's in charge of the system, they know from that permit. Some say it's a cash grab. Rebate programs. So if there's a reason to do your building now, this is it. All other things. One day you got to do your building, why not do it now? So there's 3 programs. There's a lot of companies out there, consulting firms, that just do this. Basically, they charge anywhere from $45,000 to $6,000. You get $3,000 back, so up to 75%, max level is at $3,000. So this is a great thing because, again, EV ready plan. They pay for the plan if it's a plan for one charger for every resident. If you go in there and say, well, we're putting 4 in visitor parking, you get nothing. So it's an EV ready plan. And the idea is, okay, what does your building look like with 100 or 200 chargers in it? Like, what's the cost? Is it capable? All kind of stuff. Once you know that, even if you don't do anything, now you know. And future councils might say, okay, it's time to act. Let's look at the report. We got problems. We got to do our, service upgrade, those kind of things. So just one thing on service upgrades. So I mentioned almost 1,000 buildings. When I had one building that we had to do a service upgrade. So capacity is not an issue. Grid might be an issue down the road. Not our problem, not a Strata problem. So luckily it's somebody else's problem. And right now they realize it's a problem. So they're working on that. It's just, it's going to take time. But it's also going to take time to do a lot of buildings. So anyways, the other one is EV infrastructure. So this one is, so there's two things here. It's $600 per park install, up to a maximum of $120,000. So if you got 100 stalls times $600, that's how much you're getting in a rebate. Unless 50% of the cost is less, but that's how much you get. And then if you put in chargers, you get $1,400 of credit per charger, up to a maximum of $14,000. Up till April, this was $25,000. They lowered it back down as the federal ZBIP NRCan component came out. They ran out of funding or wouldn't fund it anymore. So currently, right now, total rebates available for any strata, legal strata building is $137,000. So if there's a reason to do your building, that's it. And it's free money. There's no strings attached. The other thing I should tell you is that, about 80% of the projects we do qualify for rebates. No problem. We manage the rebate process. But about 80% of them, you get 4 months to do your project. Almost none of our projects get done in 4 months. It takes 9 months. So what we do is we basically ask BC Hydro for an extension. And almost, over 80% of our projects need an extension. We've always got the extensions. The main thing they want to know is, are you actually going to do this project? So if you're saying, well, we still got to go to an AGM and it's in 3 months and all this kind of stuff, as long as there's a reason to date, they've always extended it, and most of them extended it twice. So what we do is we keep them up to date. This project's still underway. This one's, we kind of give a progress of where all of these rebates are. The main thing we want to know is, can we just release these funds and put it back in the pool? That's what they want to know. They're very encouraging with this program. They're very, been very, very good to work with. So, and again, $137,000 for most building. That's a good chunk of change. So, questions now? Yeah.
There's a few. So, a few people have been asking about open or outdoor parking lots, townhouses, how that's approached.
Yeah. So, biggest difference. If you look at most areas like east of British Columbia, is most strata properties have surface parking. The only difference is technically everything's the same except the surface parking involves civil work. So once we're in a parking garage, we scan before we core. We're dealing with metal and concrete, so it's kind of like a fix. When you get into outdoor space, it's like, okay, what do we got to get between? We got to go over sidewalks and and landscape. What's underground and things like that. So it becomes just a little bit more complicated, but certainly doable. In other areas, like I was in Halifax 2 weeks ago and looked at a bunch of properties, they were all surface parking, like no underground parking at all. And so that's a reality. There's no challenges. I'm not sure what the specific question is, but no challenge at all. A lot of the rental buildings we're doing for rental companies that are building operators that own multiple buildings, a lot of those are surface parking. So it just, again, a little bit of civil work, but no challenge.
Okay.
There's another part to that. Townhomes. Okay, so townhomes are an interesting beach. So we have a lot of multi-use buildings where there's a tower and then there's townhomes, and they all share the same parking garage. So they're using. So really the question is, in your townhome, in your garage or in your utility room, do you have your own meter and your own panel? If you do, you're not part of a shared system, so you don't really need all of these EMS components. If you're using common power, where there is a lot of buildings where, I've got a garage here, my door goes into my townhouse, and there's a plug right there, that's shared power. Everything in the townhouse is private power. So that's the first thing we got to determine. The biggest challenge in townhomes, just like single-family homes, is most have like 60 to 100 amp panels, and a lot of people have added like a hot tub or an air conditioner, and they just don't have any more room on the panel. They don't have the capacity to add another 40 amp breaker. So in that situation, what we do is we could add a little mini EMS, which is basically called a demand controller, and it goes on your panel. And if your panel operates during the day or during the night, and it goes above its maximum peak, which is 80%, it turns off the charger. And then when the power goes down, it turns it back on again. So it's a fairly easy way to do it. And I would say about, maybe 40% of single-family homes and townhomes have to do that. The other thing of caution in townhomes and a lot of things, doesn't happen a lot in strata properties, but in single-family homes, I go to so many homes, and we look in there, and you say, this was not done under permit. Like, this does not meet permit or code. If we apply for a permit and say, we want to put in a charger, and they come out and look at this disaster, they're going to shut your, they're going to make you redo everything. So it's a horrible space to be in because you don't want to be that guy, but we don't do anything without a permit. I mean, we're going to, we pull a permit, this is a disaster, we'll fix it for you. But, and a lot of people purchase their home with that kind of problem. And, that's a totally different deal. But, so if it's overloaded already, and most homes are overloaded. If you've added anything like, added basement suites, it's overloaded, guaranteed. We can't get a permit. But when we put a DCC on there, like a demand controller unit, we can get a permit because it automatically controls any overload. So it's a good solution to that problem.
A subsequent question to that is noting that surface parking is often a bigger area than a garage, so presume the cost will be greater. Is that accurate or inaccurate?
So yeah, the biggest cost component is distance is a big thing because there's voltage drop the further you go. It's like an extension cord. You get about 100 feet, your system doesn't work anymore because there's not enough. It's too long. So does that mean?
Oh, no, that's
okay. Sorry. So the biggest component. So if we look at cost of the project, the biggest cost component is in your main electrical. How do we get enough energy for all these chargers? And that really depends on the type of equipment there. Is it 600 volt? Is it 480? Is it 208? Do we have to step down? Do we need transformers? Is there enough physical space in the room? A lot of buildings, what we have to do, we have to build a mini electrical room in the parking garage, and we fence it off and chain link fence it. But because there's no physical space in the room, so that's all added cost. That's number one cost component. Number two, when you get outside, you have to go through a lot of sidewalks, a lot of civil stuff that's under the ground. That's another component. Distance not the biggest thing, but there are other factors. But again, when we do the site visit, that's the first thing we determine.
Okay. Kind of a specific question. This person's building has a charger with no systems for the two users to pay, so everyone in the residence are paying for them to charge the vehicles. And they're wondering how they charge the users for using the charges. I don't know if that's your question.
Yeah. Well, typically what they do is they do a flat fee. If you're going to use the charger, you pay $50 or $20, something like that. So it's a guesstimate. Mm-hmm. The big challenge we've seen, and we're far enough along this, is that eventually a resident, like we've seen buildings where people have stuffed popsicle sticks in electrical outlets because they see people plug out a charger, like a little bike charger in there. Like they don't. I'm paying for that. I don't like that, and they're mad and they complain, but they see it and they don't like it. It's the same thing with a charger. Okay, so we guess it's $50 should carry it, but we're not tracking it. It can't meter, so we're just guessing. It's a guesstimate. 2 chargers, not the end of the world. But just extrapolate that out to put 200 chargers and you're guessing. That's a dangerous guess. So the other thing about most installations up to about 2 years ago, it was very common to put a couple chargers in visitor parking. So just if you look at the user case, most buildings had 2 to 3 electric vehicles. So technically, it's like they almost have their own private charger. Take the same 2 chargers and you got 20 vehicles. Now you get complaints about they're parking there too long. Why are they, a non-EV's parked in the stall. They're hogging. And we've been in buildings where they just said, we finally just shut them off. We're tired of all the complaints, problems, and all that kind of stuff. So we highly suggest a turnkey solution that's where the service is provided by somebody else. If they got a problem, they phone the other company. And also with meter and monitoring, very common is so in visitor parking, Owners can have one rate, say they pay 15 cents a kilowatt hour. Visitors pay 20 cents a kilowatt hour, and then people you don't like pay 30 cents a kilowatt hour. You can do anything any way you want it, but also you can do forced enforcement. So what you say is you can park 2 hours. After that, it goes up to $5. Guarantee people are moving their cars. With a dump system or an unconnected system, you don't have those abilities. So eventually, it just ends up being a pain in the butt, and you need a better solution. So unfortunately, what we've really tried to do is we try to emphasize, if you're going to do something, look at the big picture. Even if you're going to put in 2, don't let us come back in a year from now, rip them out, put something in. Just put them in as part of the overall plan. Even if it's 2 or 4, you start in visitor, have a plan for, so just think it through. And again, that be ready plan kind of provides that picture of the future and see what your building looks like.
I think the other piece for a building like that, and what I really learned from you at the park about the peak demand impact, is traditionally when an owner wants a charger in, they're just looking at kilowatt hours and then sort of doing the math on the minimum charge that they assume they might use. Like, it's only going to cost $9 a month, so I'm not going to pay 25, I'll pay 9. But that peak demand, at what worked out to about $75 a car with 25 EVs, is that whole other piece that I think as a council, if you're going to have that open system, that it's going to seem much more expensive than something you might expect. Because I was talking to car salesman, he says $9 a power. Like, in a single family dwelling, absolutely. Yeah. But in a condo, if it happens to be at the wrong time, it can end up being $75.
A very common kind of comment is that people would like to just go on Amazon and buy their own charger, plug it in. So just give me an outlet, I'll plug it in. Okay, it's a great idea. That's for a single family home. That's if you have a meter, you can just plug it in. A lot of times in parking garages, the meters are in the garage. And they say, well, just look up my meter. Yeah, but your panel is on the 22nd floor. Like, it's the technology is not there to figure that out, and we can't do that under electrical code. So the other thing too is, the harsh reality is that this is co-op charging. It's kind of like I use the term communist charging. Is that whether you like it or not, everybody's in this together. Somebody has free charging. There is no free charging. It's like BC Hydro was free up to May of last year. You could charge for free. But no, it's not free. We're all paying for it, right? Like, it's not free charging. It's just who pays for it. So in a building, who's paying for it? If council, on behalf of all the owners, say, we don't care. And we do have some buildings, they say, we're going to charge every $50 and we don't care. We actually didn't do the building because, we just fundamentally can't put in the system that a year from now they say, why would you put in the system? Yeah, you're right. Well, the two councils ago, wanted to do it a different way. We just can't stand behind that in a residential parking garage. Out in the public space, Bob's your uncle, you can do a lot of different imaginative things. So again, kind of keep in mind. So the other thing is proprietarism. They say, we don't want a proprietary system. Okay, so if you look at all of the solution providers in Canada, there's over 40 of them. I've never seen a building walk in and said, there's a flow and a charge point and a switch and a Siemens and a mixed bag. Number one, you got 20 different subscription monitoring agreements. Somebody's got to manage. It's a disaster. One's based on cell, the other one's based on Wi-Fi. It's just not an efficient way to do it. I think the fact is you got to face the reality that we have a shared system. We got to do this all together. It is a walled garden. Somebody have Apple, somebody have Android. You got to make a decision. So, all of them by definition are, like, even a lot of them claim to be OCCP, which means they're open protocol. Well, they're not open protocol. Like, nobody runs those systems. ChargePoint runs their own systems. Nobody else runs their systems, right? So it's proprietary. It's not a bad thing. You want them to be responsible for their system. We put it in, we did it to your spec, make sure it works, right? And when somebody has a problem, make sure they're taken care of. And if there's a problem, call us and we'll go and deal with it. So in the end, they're all proprietary. Technically, just get over it. And if you don't go with that type of solution, you're going to pay in the long run. It's very, very nasty. So, we've seen that. As I mentioned, legal challenges on somebody saying, how can council prove to me that I'm not subsidizing somebody else charging in the building? Obviously, somebody that wasn't a big fan of EVs. And they couldn't. We have a building with the EMS system in it, and they could. They could prove that here's all the costs. Here's everything that's been collected. Nobody else is subsidizing. Only the EV owners. And a lot of times, like up to a couple of years ago, really the sell was the fear sell of people that hated EVs. So I said, no, you want a system to make sure that you're not helping pay for the system, right? Because in reality, that was what we were doing, was make sure if a guy wants a charger and they're paying the freight, good on them. They're going to pay the energy cost and the installation cost, great, right? But they should have a right to do that given the factor in share.
Just have a quick question about infrastructure. I was under the impression previous to this that the most expensive part of the infrastructure operating would be like the cable and conduit runs. But you talked about equipment upgrades as you mean in the electrical room, building a secondary electrical room, even though a building might be EV ready. So if you had a building that had roughed in a conduit, how much of a savings would that be? I'm going under the assumption that maybe they don't have the equipment electrical room that's necessary to do that.
Yeah.
Like how much does that save the conduit and roughage or whatever?
Yeah, I mean, there is a savings. In reality, there's a couple of components that change things. One is most buildings, like in most jurisdictions, they had some type of, you got to put 20 chargers or 10% of your parking garage has to be pre-wired. So what they did is they ran conduit, or they have to be EV ready. Well, what does EV ready mean? Up until a year ago, there was no definition. So a junction box with an empty conduit and a pull string was EV ready. On the other side, there's no panel, there's no breaker, there's no electrical capacity. But this is an EV ready part. So when we go to the building and say, no, these are all EV ready, and we say, a string is not EV ready, and there's no breaker, panel, or capacity. So that was kind of like no man's land. The vast majority of buildings out there are like that. We have 10 chargers, or 10 pre-wired stalls. They're usually in visitor parking, or somewhere that's not convenient. They're not down in P4 in the very far corner where somebody actually wants a charger. They're here. So we have 10. They're not circuit shared. They're just dedicated lines. So we need to kind of remove that and put in circuit sharing. So, there's shared circuitry throughout the parking garage to make sure we can maximize the power and coverage of the building. So a lot of times that ends up being a liability. But one of the biggest costs is the actual conduit, like the EMT. It's a huge cost. It's gone up like 300% over the last year because of global shortages. So we avoid using conduit in any area we can. But the run that actually goes down into the parking stall, we still use conduit. It's not the biggest cost, but it is a significant cost.
There's just a couple other things here. Somebody asked for EV vehicles being a rapidly advancing technology. Are there concerns with some of the current technologies being obsolete in 5 to 10 years? What is that?
Yeah, again, like your phone, you might need a different nozzle. You might need an adapter. See, most of the companies, the J1772 has become kind of the global standard. They've done away with Chatham, which was big on hybrid vehicles. So now at the superstation you go, you used to see a CCS plug and a Chatham plug. Now they're coming with both the CCS plugs. So they're actually reducing the amount of complexity of the system. We don't really see any leap in technology. If it does, it's probably going to take a decade to get through. It took a decade, well, it took 2 decades to get to the J1772 standard. The way we charge vehicles, a lot of people say wireless, or you can drive over a pad. I mean, technically, you still need a device to capture the energy that's going through the pad if it's wireless. So instead of a nozzle, you have a pad that you drive onto or whatever. So that will evolve. I don't think there's any way to future-proof. I mean, we've all replaced computers and cell phones over time. Why? Not because we had to, because we wanted to. So that's one of the risks we take. But again, like the wall outlet that's on our wall, it's been there for 100 years, same plug, still provides energy. What we plug into is quite different, but it's kind of the same technology. Chargers like that. We put a system in a building, it'll function forever. Now, there might be sexier systems out there. Your system still works. Doesn't stop working. And if it needs to adapt because of nozzle change and things like that, we don't see a problem.
And just one last one. With the EMS controls for chargers, the person was wondering your example of a rough example for what about larger buildings? Is there a potential that there isn't enough capacity for all the vehicles to gather enough charge overnight?
Yeah, so the minimum standard almost every jurisdiction in BC has set is that a system at minimum performance must be able to deliver 12 kilowatts of energy over 8 hours. You do the math, that's 1.5 kilowatts, or kilowatts of energy to each vehicle. What we found, and what most jurisdictions are looking at, is that you can actually lower that. That's actually overkill. People don't need that much energy. But regardless, we use that. So all of our systems are designed, technically they're designed at 1.66 kilowatts. So that means if you have 200 vehicles, they're all charging at the same time, they're all going to get 1.66 kilowatts at the same time. When there's less vehicles, again, all that energy is dynamically redistributed to any vehicle that's being charged. So a level 2 charger running at full tilt is 6.6 kilowatts. Worst case scenario, if everybody's charging at the same time, you're going to get 1.66 over that period of time when everybody's charging. Now, we have thousands of chargers in the field, and what our stats show us up to like last week is on average throughout British Columbia, people charge for less than 2 hours on a daily basis, and they're using 168 kilowatt hours of energy. So it's about half of what our provincial kind of like targets are. They targeted 300 kilowatt hours average usage. We're actually seeing it about 168. And we're getting pretty good data. We have a lot of heavy users and a lot of realistic scenarios. During COVID, we really put a pause on everything because we've got who knows what's going on now. Like are people driving more or less or none at all, things like that. Now we see regular trends. So the systems themselves are designed to future-proof. It's not like one day. There are companies out there, and should be warned, is there are engineering firms who everyone believes they should know what they're doing, are actually designing systems 12 to 1. Okay, so you take a 40 amp circuit and divide it by 12, that's less than a level 1 charger. Now, not saying that they won't work some of the time, but I don't think that's a good way to future-proof your build. We maximize it 4 to 1. If somebody says, no, we want you to do it 8 to 1, we're the wrong people. We don't want to do that. We don't want to name one your building. So we're kind of hard doing that only because all of the technology that, is developed, all of the specs that are developed in Europe and, through the United States, especially California and New York, where they're kind of on top of the stuff. And then around the jurisdictions like Richmond and City of Vancouver, where they really deep dive into this. When they come out with this, it's based on a lot of data we can't get. They get, and they say, this is what we believe the minimum should be. We take that for granted because it's based on a lot of good, a lot of good research that we don't have access to.
There was, one last question. I'm not sure if you're the person to answer it, but are you aware of any impact on strata insurance costs after EV?
Yeah, that's a good question. I get asked a lot. So far, we haven't had one building or one owner that said their insurance rate or policy changed at all. The insurance providers have told us they recommend that you register the charger, as part of your property, but there's no change to your premium or your policy to date. We do dialogue with like Intact Hub on a regular basis, just on policy, what they see coming down the road, and so far it's